Yo, what's up, Jason? How's it going, man? How's it going, buddy? What's up, SPL Society? Notification squad right here, isn't it? Notification crew. Steven's repairing a MTX TA7801. Can't actually picture in my mind what that one is right now. The 7801. 7801, 7801. It's not one of the weird ones that runs the power supply FETs backwards, is it? Where you get a PWM on the source and gate, but nothing on the drain. Is that one of those ones? Oh man, the clamps in this Hertz are very, very hard to get off. They're like very, very, very tight in here. Thanks to Alex Stone. How's it going, buddy? That's alright, no worries. Thanks for jumping on and saying hi. Let's try and get this out without damaging this cap here. There we go. Cool, cool, cool. Yes, you got it. Oh, nice, nice. Okay, yeah. Yeah, weird. I actually had somebody message me the other day about that. They were repairing an MTX. And they were like, dude, I'm so confused. How is this thing currently working? He'd actually fixed it. It was just an output section repair. He was like, yo, how is this thing currently working? I don't understand. I got audio, the output section is switching, but the power supply, I've got no pulses on the drain. What's up with this? How is it working? I was like, yo, dude, check the source, bro. You see a wave there? Weird ass design. Charles asks, do you have a video of how to repair an amp to see what the problem is? I have an oscope, cheap one. So basically, the way that I've been doing videos or live streams these past few years is in order for me to be able to make this content, but also still actually repair amps, you know, and actually not use up all my time creating this content. I have been for the last few years live streaming my repairs, just like I'm doing today. So where I'd otherwise just be sitting in the workshop repairing an amplifier, I turn the cameras on, chat to you guys, and kind of talk through what I'm doing at the time. Now obviously that is content that's being created live at the time, rather than content that is created by making videos, editing it together, that takes time, etc, etc after the fact. The problem with live content is obviously I don't know what to expect, so I don't know what kind of video or content I'm going to be making today. It just depends what's wrong with these amplifiers as they come in. So that sometimes makes it difficult to obviously predict what titles to give videos, or you know, and also do so many of them, and so much of these live streams is actually just filled with talking to you guys, taking the amplifier apart, putting it back together again, etc. That it's quite difficult when someone asks, oh hey, I've got this specific fault, what should I do to look for? And I think, oh well, I've definitely covered that like loads of times in live streams, but I wouldn't know where to send you. And that's just the nature of doing live content. It's obviously you have to be there and then, otherwise it's difficult to kind of look back and find some certain content. But that's how I've been able to do it and still do my job, still repair amplifiers and also show you guys. However, saying that, I have been considering making a properly structured amplifier repair tutorial video series. And now this video series will be monetized. It will not just be for free on YouTube, because I need to be paid somehow for that time that it will take to create that, rather than just like the live streams are free because I'm doing this anyway. Like it doesn't take me any more time really to do this than it would if I was just sitting here doing it anyway. So the live stream is just free content, but obviously that comes with its drawbacks. But the thing that I have planned, a amplifier repair tutorial video series, will obviously be monetized, and it'll be on some kind of platform where you'll pay for the series. So yeah, I will be planning a video like that. My man, I can't remember where they were now, Charles, I am planning videos like that. So watch this space, and I will let you guys know where they will be as soon as I have planned it and as soon as I know what's going on with it. But it won't be like next week. It might be like this year, maybe next year, something like that. All right, see what we got going on in here. Honestly, right, my goal for the amplifier repair tutorial video series, if you can't having watched the video series a couple of times, then start instantly repairing amplifiers and either making money from it or getting your stuff fixed, then I will deem myself as a failure. The intention with these videos, this video series, is literally to turn anyone with no electrical knowledge, background or training into an amplifier repair technician. So don't worry, the videos will be great. You will learn and you will be able to fix your amps. I just need time to actually do it. And right now, my time is being taken up with four main things. My time is being taken up by four main things. Firstly, obviously, amplifier repair is my main business. Repairing amps, that's how I make my money. Second thing is taking up my time. Boom or bust. It's freaking great. You guys wait. Oh, I can't wait to show you. It's freaking incredible. Third thing is taking up my time. The Proton. It's given me some grief recently. I'm having to learn how to work on cars, which is not something that I've ever wanted to do, but I'm having to learn how to work on cars because I'm not paying $2,000 for someone else to work on my car. And lastly, the last thing that's taking up my time is other video ideas that I've got aside from Boom or Bust, like, for example, Class AB versus Class D, similar to the Crown Turrets video that I put out recently. So four main things taking up my time, and obviously existing, cooking, cleaning, household, spending time with a partner, seeing family, etc. So yeah, it's busy times, but man, I can't imagine having a kid. Holy shit! How do you do it? How do you do it? I don't even have kids, and I'm busy as hell. I can't imagine throwing a kid into this situation here and like having all that as well to deal with. But people do it, so anyway, what's up with this amp then? Here we've got a Hertz EP1D. This looks like a pretty cool little thing. It's not a generic circuit layout. It is Hertz do use generic circuit layouts, but they'll modify it slightly. It'll be their own it'll be their own layout, but it might be based on a generic design. So here we have a little Class D mono. Power supply side is all over here. We've got two transformers. We've got two FETs, one push, one pull per transformer. Nice and easy stuff. It is run by an SG3525, so similar to the TL494, but with a bit more features. SG3525 is actually a pretty nice chip to run with the power supply, has good protections built in and stuff, lots of inputs and outputs you can use and tie up with things in the rest of the circuit, so yeah, pretty cool. Output section, we have a single mono channel over here. Yo! Check it out. Thank you so much. Thank you very much. Wow, it looks good. They came out so well. I'm actually so surprised. It was really cheap, wasn't it? Oh my gosh. Wait, have you had yours yet? No, you're gonna, yeah, alright, sweet, alright, sweet. Oh, yo, check this out. Absolute delivery service right here. I got myself a waffle, a chocolate waffle. We actually bought this, I was just in the supermarket the other day and they had this waffle maker on like reduced, like very, very cheap discount, like a mini waffle maker. And I was like, Valentine's Day is coming up soon. This looks pretty cute. Let's grab that. So let's see how that goes. Man, that is good. Oh wow, that's actually so good. Holy crap. My man. So yeah, like I said, we've got the output section over here. We have, this is just a half bridge. So we got two FETs for low side, two FETs for high side, single inductor, and we also have a secondary filter inductor here to clean up the signal even more. We have a relay that isolates the speaker terminals, nice to see. We also have a bipolar filter capacitor here running in conjunction with the film cap. So there's lots of filtering here. Should get a nice clean sine wave on the outputs with not much Class D switching noise. Okay, so I'm just currently seeing what the issue is with this amplifier. I'm pretty certain that when this was in the heatsink a minute ago and I probed these output MOSFETs, we had a short circuit, but now it doesn't seem like we do, although we are seeing some strange values here. Take a look at my multimeter cam here. Okay, so we've got the multimeter set to diode mode, okay, and diode mode is basically looking for voltage drops, but it also kind of, you can also kind of get an estimate for resistance with it as well. But the reason I use diode mode is because it gives me a nice beep when we have continuity. It's also a continuity finder mode. So basically, if any of these MOSFETs have continuity between any of their pins, then that's a problem. So it's nice and easy for us to hear instantly whether there's a problem. Usually when we read output MOSFETs like this, we generally tend to see between 3 to 500 on the meter between gate and source. We've got a 184. Now that is the same across pretty much all of these, low side and high side. Now if we flip the probes around, usually the number changes because the voltage drop is different the other way around. If it's the same, then this could be a problem. Okay, it's not. It's actually different. Okay, so that means that we haven't got a 164 ohm resistance between drain and gate and source. Just means that the voltage drop is like that with the probes that way around. I'm a bit confused now actually, because I'm pretty sure this had a short across these FETs when it had it in the heatsink. Anyway, let's power it up and see what it's doing then. So we've checked that there's no shorts on the output FETs or anything like that. So we're safe to power it up and see what it's doing. So I'll read this from live chat. The chewing sounds are making me hungry. Oh yeah, my bad. My bad. It's always difficult when you're like live and someone hands you a snack and you're like, oh shit, I've got to sit here and eat this now. Man, this is freaking great. Okay. Hold on a minute. So, Stephen Nelson, just said something that made me think about what else could be wrong with this amplifier. This amplifier has been sent in. The customer states that it is making a clicking sound and no audio. So I'm thinking, right, what could be making a clicking sound? Clicking sound could be a shorted output MOSFET, which is causing the power supply section to try and oscillate, fail to do so, which causes like a kind of click spike on the transformer here, and then it will try again and again and again to try and build rails, and it will fail to do so, and every time it tries it might emit a clicking sound. So that could have been one issue. Another issue could obviously be the relay over here. That will make a clicking sound when it engages. If there's a fault with the relay engage circuit, then the relay could click on and off, causing a clicking sound to the customer. No audio. And another thing that could cause a clicking sound is a drive circuit fault or something preventing the output section from oscillating correctly. Now, I don't think there's going to be a drive circuit fault here. We have equal multimeter readings across both low side and high side here. It doesn't mean that that's definitely the case, but it's unlikely to see a drive circuit fault here. The Hertz driver board actually is quite nice. It's relatively well designed, and I'm honestly not expecting there to be any problems with the drive circuit. However, the comment that Stephen Nelson made, I actually misread it, which is why I thought, oh, I'll check that. He said short through the insulator on the heatsink. I read that as short through the insulation on the inductor. That's what I read when I read that comment. So the insulator on the heatsink could be a problem if there is a short circuit between the MOSFET backs through the insulation that connects it to the heatsink. That could cause this issue as well. However, if we take a look at the heatsink over here, it's that hard kind of I want to say mylar, is it? And that doesn't really get holes in it. It's not like the thermal pads, they get holes in them, so it's unlikely to be that. But because I misread Stephen's comment here, I'm going to take a quick look at the inductor, because that is a very common issue, especially in an amp like this where it's not seated down properly. Look how wobbly that is. I mean, come on. How much money do people pay for Hertz? Yes, this is quite a cool, nice little amplifier, but the build quality is atrocious here. Look at this. You're installing this into a vehicle which on its own, okay, is vibrating, road noise, bumps in the road, moving around, G-forces. Then you throw into the mix a subwoofer, and you're likely mounting this amplifier to the subwoofer box or to some kind of material that's going to be vibrating along with the bass frequencies. This needs to be seated down. Come on. Anyway, let's have a look then and see whether there's any evidence of rubbing where these leads touch each other. Oh, hello! Hello, my friend! Hello, darkness, my old friend. Now that looks distinctively like the inductor insulation there has rubbed through and it is shorting this lead to this wind, and that will be basically cutting the inductance in half, completely changing the characteristics of this output section inductor. So I'm pretty sure that that's all is wrong with this amplifier, and fair play to the circuit for actually holding up. Usually it would kill the output FETs given this scenario, possibly. So the way around that this failed was obviously done so in a way that hasn't killed the output FETs. It's also rubbed not only in that position, but I've also just noticed there's another bit of rubbing on this position just here, just underneath this one right there. So yeah, quite a few spots that this has rubbed in, although I imagine that's probably going to be it. So two things we need to do with this inductor. Firstly, we need to isolate the shorts. Secondly, we need to seat it down much better so it's not going to move around in the future. And let's see if my Tessa tape is up here or if I've left it downstairs because I was using it for boom or bust. See, some electrical tape might do the job, but I honestly prefer using Tessa tape for this because it is like a material. It's very difficult to break and rub through because it's like a fabric, so it doesn't really rub through or break when you have it rubbing together. What I might do is I might throw some electrical tape on first and then follow up with some Tessa tape over the top just for extra insulation. So let's cut some electrical tape off real quick here. What time is it for everyone here? Here it is 3:04 in the afternoon. So I've done a couple of amps already today. Just thought I'd jump on the stream after lunch and show you guys this Hertz. So yeah, firstly electrical tape and then secondly Tessa tape, which will prevent the electrical tape being rubbed through if there is any like excessive vibrations in the future as well. This actually probably isn't such a bad way of doing it. The electrical tape will have the voltage insulation that's required, because I don't think Tessa tape, I don't really know what rating it has for voltage isolation, but the electrical tape will obviously have that, and then the Tessa tape will prevent any rubbing through from future vibrations, etc. So we're just going to isolate and insulate this top lead because that's the one that has a couple of rub spots on it, firstly. Then we'll get to seating down the inductor better in a brief moment. Nail polish, yeah, that also works great as well. Personally, I don't own any nail polish, but maybe that's a good shout. Nail polish would work really well for this. It basically rebuilds that kind of laminate layer on the wire, the laminate coating. Okay, not the prettiest thing in the world, but it is isolated just for a quick test at least. I might rip this off later and replace it a bit nicer, but that has now that has now isolated the short, so it's not shorting to its own winds anymore unless there's any more further down. So let's plug some power wires in and see if that's all it was. It's a shame actually because I didn't actually need to take this thing out of the heatsink, but it's always not a bad idea. Sometimes you can have you can actually find more problems when you take the board out of the heatsink. You can find vibration damage that is working its way in with the MOSFET legs and stuff like that. You could find crap that has got its way underneath the board, blown traces that still allow the amplifier to actually function but are blown. So it's always a good idea to take the board out of the case anyway. Kishan says, "I wish I had your brain." Lol. Brains are all the same, really. It's all made of the same mush. It's just how it's programmed. I guess that my upbringing and lifestyle has kind of programmed my brain in a very troubleshooting, logical, methodological way. And you can program yours like that too. It's just the tasks and activities you do and the way that you think, and you can change the way that you think. Yeah, it's really, really easy. Change the way that you think, change the way that you look at things. I honestly feel that we are all somewhat capable of doing anything when it comes to like mentally, not necessarily physically. Some people are very skilled, talented when it comes to like physical activities, hand-eye coordination, sports and stuff like that. But when it comes to like troubleshooting, problem solving, I'm pretty sure that anyone can be trained in a way to be good at it. Alright, so I'm just going to give it 10 volts and about 4 amps, and let's power it up and see if we have some output switching on the FET. So I'm just going to give it a couple of little quick pulses, get some rail voltage built in here. So here we have hopefully the high side, and here we have the low side. Yep, looks good. Oh, it's cool, that came up really quickly. Reject low frequency, get my scope turned to the right settings first. There we go, nice. Oh, it's actually kind of bumping around a little bit. It's actually phased. That's because my voltage here is fluctuating around. Let me get that cranked up. There we go. Just hold it on 12 volts. There we go, that's better. Just my power supply screwing around. It's quite old now, my power supply. Some of the potentiometers are a bit dodgy. You have to kind of wiggle them to get the voltage to be stable. But yeah, it looks good to me. 0.9 amps worth of idle current draw. That's what we like to see. And yeah, everything's working fine. So while it's powered up, I'm just going to give the inductor a wiggle just to make sure that there's no other spots in there that are kind of rubbing their way through or shorting out. No, seems good to me. So all that needs now is just needs this making look nicer, perhaps, if you care about how it looks. Yeah, we just need to run some sealant along there to seal it down and get it seated down so it doesn't move anymore. So I'm just going to run and grab some. I've got my paste gun downstairs. I'm going to run and grab that. One sec. So yeah, I've had this downstairs because I've been doing boom or bust. Been building the test cabin, test volume. Man, I'm so excited to release this video. I am halfway through editing episode 1 of Boom or Bust, and it is freaking sick. It is so cool. I'm putting a lot of effort into the production quality of it, so hopefully you guys will enjoy. it almost feels like this kind of negligence in the assembly quality. It feels like planned obsolescence. Like this was always going to fail. This inductor is so loose on the board here. It was always going to fail at some point. It's hard to think that that wasn't obvious when this was being made. There we go. Once that dries, this ain't going nowhere. This is some really strong stuff, this. But it has enough flexibility in it for it not to be brittle under vibrations, but this inductor ain't going nowhere. Lord pray no one ever has to take it off the board ever. Will you glue the other inductors down as well? Yeah, it's a good idea too. I mean, these transformers are actually a lot better. Like they don't have any movement on them whatsoever. This one over here, again, no movement on it whatsoever. So yeah, these ones, I don't know. They seem to have some kind of coating on them, but the output inductor just didn't. So there's actually going to be no benefit to me doing these ones whatsoever. They're already stiff, like there's no movement. What this will do is this will help to keep a loose component seated and give it a little, just enough wiggle room so that it's not brittle, so it doesn't snap. But these things, absolutely rock solid. Like I can't get a single bit of movement on that at all. So that's not going to benefit from this at this time. What we do need though is some fresh thermal paste. What thermal paste do you use? I use, I'll get it out in just a minute. It's probably not, the thermal paste I use is bulk stuff, because it doesn't need to be, wait, where the heck is the screw that went in? The thermal paste I use doesn't need to be extremely high thermal transfer, because the surface area of these MOSFETs is quite big. So and also the amount of heat that they generate it slowly rather than in like sharp spikes. So basically you need really high transfer rate like thermal paste for computers, CPUs, because the spike in amount of heat that is generated in a CPU is very sharp and very short. Small processes and instantaneous loads you put on the processor heat it up insanely fast. However, with these MOSFETs, it's a lot less of a sharp amount of heat that's drawn. It just needs to be able to dissipate the energy eventually to the heatsink. I don't really know a good way to explain it. I'm sure it will come to me, but you can run an amplifier like this through with a speaker connected with the MOSFETs not clamped to the heatsink for a small amount of time, obviously depending on how much load there is, but for some amount of time you can do it without any damage. However, if you run a computer CPU without a heatsink on it, even for like 5 seconds, then it shuts down because it's already got to 100 degrees Celsius or more. So it's a slower cook, and therefore the thermal transfer paste is less important for its specifications and ratings. All it needs to do is just bridge the gap between the MOSFET and the heatsink, fill in all the air holes so that there is actually some material there connecting the two. So the paste that I use is this stuff. Does it even have a brand? It's 180-3510. Oh, RS Pro. Here we go. It's just RS Pro's own stuff. Yeah, it's not very high watt per meter Kelvin, whatever that is, 1.4, but it's absolutely fine. And it's actually probably the same or better than what they use from the factory in these amps. So there's no point. You're going to go bankrupt very quickly if you start using like Thermal Grizzly or some kind of Noctua really high-end computer thermal paste when you're doing this kind of job, because you get through so much of it, and honestly it's not going to benefit the amplifier really in any way. Do you use thermal pads as well? Yeah, pads go between them. Some amplifiers come with SealPad 900, for example. SealPad 900 is very expensive. You don't need paste to go with it, but it's very expensive. Alright, cool. Yeah, it just needs to hammer these clamps back in place now, and then we're good to go with this one. Charles says, I've got a few amps that power up no sound. Point me in the right direction. Lanza Opti 2000x4, Fosgate 400x2, same thing. All power up, no outputs. The most common reason for power up, no outputs is actually the switches on the side of the amplifier. Just like this one here has a little switch here for output master or input slave. These switches, they are notorious for building up a layer of kind of oxidization on the contact rails, especially if they're not moved in a long time, and that actually prevents the audio signal from passing through them. So first thing I tell everyone who comes to me and says my amp powers on but no output is I say clean the switches, get some isopropyl alcohol, clean it on the inside and outside of the switch, flick it backwards and forwards many times, and honestly I'd say 8 times out of 10, that fixes the problem. And people are like, yo, that's great, my amp's working now. And I'm like, yeah. It's much less common for the amplifier to have an actual fault with the circuit or something that actually prevents audio from getting through it to the output terminals is less common. You know what I do? People that have that issue, I don't even tell them to send the amp in to me. I just say, hey, check this first. If that doesn't work, I'll happily look at it for you. Because yeah, I could be making 25 to 30 pounds off of every one of those amplifiers that just has the bad switches. But I'd rather the customers not waste their money on postage or get the risk of damaging postage from sending me the amp when it's something so simple that they can just do. So I probably lost a lot of work by giving out that advice, but at the end of the day, it's fine. Someone asked me, what glue did you use for the inductor? Nothing special. It's just this kind of this adhesive stuff. So yeah, be fine. It's not super critical what you use. It just needs to create a. It just needs to be some kind of adhesive that has a bit of flex in it, but not too much flex. That can grip onto non-porous surfaces, that will hold the inductor in place, create like a kind of seat for it to be in that holds it tight. It's not super critical what you use. Some types of silicon will be too rubbery and too flexible and allow a bit of vibration still, something a little bit stiffer than that, but you don't want to go for something really brittle and crumbly, like, I don't know, some kind of what's that called, that sealing coving adhesive. You don't want to use anything like that. You just want something that can create a nest for it to sit into and hold it tightly. Got Lowe's says, had any experience or can offer advice on a Sound Magus X3200. Option order used the same boards. It immediately goes to protect and makes a buzzing noise from one of the inductors. So if it immediately goes to protect, it means that it's either not able to build rail voltage, or it's not able to start class D switching, or it creates DC offset. It means that there is an output section fault. Basically, if the amplifier tries to power up but goes into protection, it means that there is a problem in the output section. Either shorted output MOSFETs, which are really easy to find with a multimeter, see which ones are shorted, drive circuit fault, or similar to this one, a shorting inductor. How's it going, Blake from OKC? What's up, man? David says you got paste on the screwdriver handle. Dude, you get paste everywhere. I get paste in my eyebrows. Emil, how's it going from Romania? Sup, buddy? Thanks for jumping on. Thermal paste is kind of like radiation. You can't escape it, just minimize the damage. Man, I've lost so many nice items of clothing to thermal paste. Sometimes because the workshop is just in my house, right? So sometimes, you know, I'll be wearing a nice outfit, or come in from a nice day out or something, or put nice clothes on. I'm like, oh, you know what? I'm just going to really quickly look at this amplifier and, you know, just have a quick look, take it apart maybe. I get thermal paste on like my nice clothes, and sometimes it comes off. Especially if I notice it straight away and I spray it with some isopropyl alcohol first. Sometimes it doesn't. Sometimes it leaves a white stain, white mark on your jeans or something, and it's like, oh man, it's going to be there forever. It's almost like it kind of takes away the dye or something in the clothing. Yeah, absolutely. Yeah, some of the Korean boards, yeah, it's just absolutely caked in thermal paste. Especially the new Korean full bridge things like the Vibe M21Ks. Those are just completely, the amount of thermal paste in them is crazy. Yeah, Kush from nose, man. Doesn't come off, does it, man? It's just there forever. I'm a bit worried actually. Thermal paste is actually really quite toxic. It's actually really quite bad for you. So if we take a look at the warning labels on this thermal paste here. Suspected of causing cancer, oral. So basically, wash your freaking hands after being in the workshop before you eat your sandwich. Before I was really wise about that. Sometimes I'd just eat, like, give my hands a quick wipe and eat a sandwich or something, like years ago. But yeah, freaking wash your hands, man. Don't get this shit near your mouth. Very toxic to aquatic life with long-lasting effects. Very toxic. Do not handle until all safety precautions have been read and understood. Avoid releasing to the environment. So all of those stanky ass MOSFETs you're throwing in your regular bin with thermal paste on them, it's not good. If exposed, or oh wait, shit, it says wear eye protection and protective gloves. If exposed or concerned, get medical advice. Collect spillage, dispose of contents and container to hazardous or special waste collection point in accordance with local, regional or other regulation. So you heard it here first, guys. Your thermal paste shit is pretty bad. But at the end of the day, everything in life gives you cancer. You can try and minimize your risk as much as you can, but you got to do what you got to do. You got to work. You got to work on cars. If you're a mechanic, brake dust and whatever other crap you're exposed to working on cars, probably the same kind of deal. Alright, cool. So that's that one sorted. Let's move on to the next one. Guys, we can look at a JL Audio 1000/1, a JL Audio 500/5. What else we got? So I've got a yeah, JL Audio. Actually, I've got 3 JL Audios in at the moment. I've got the 1000/1, 500/5, a 500/1. I think that's it for the next couple of amps. I've got lots more than that to do, but they're the next ones that came in first, so we're going to do those first. So basically it's JL Audio or nothing. What do you want? Do not use as dessert topping. No, don't use as dessert topping. Someone says Class AB. Well, that would be the 500/5 probably. The full bridge one, the 1000/1 is full bridge, so could do that. I got a couple of votes for the 1000/1. Yeah, 1, 2, 3, 4 votes for the 1000/1. Don't forget to check that amp when it's back in the heatsink. Yeah, I will do. 2 votes for the 500/5. I think we'll do the 1000/1. Okay, 1000/1 it is. Let's have a look. See what's going on with this one then. Okay, so first thing I want to do is have a look inside. This is one of the older ones. The way that you can tell whether the JL Audio Slash series are one of the older or one of the newer ones is how many screws there are on the back. If it's one of the older ones, you'll have 1, 2, 3, 4, 5 screws on one side and no screws on the other side because it kind of slots into this gap here. The newer ones have much bigger bolts on both sides. So if you wanted to do that. Sean Barlow says, after the test of the SQ with the terms and the JBL, do you go for the cheapest amp with the most power? Generally, yes, but obviously there is one other factor to counter in, which is reliability. Yes, subwoofer amplifiers will all generally sound the same, provided your filters and preamps are set the same. but obviously you want the amp to be reliable. So some cheap, powerful amplifiers are not that reliable. So sometimes it's worth paying a little bit more for something that is a bit more reliable. Okay, let's have a look what we've got in here then. So first thing to look for on these is whether we have a smoked up power supply section. Take a quick look under the clamps here. Any blown gate resistors. The gate resistors all look fine, which is usually a good sign that the FETs themselves are fine as well. Take a peek over to the output section. If I can make some room on my desk to bring this over. Okay, we've got these two output drive cards, one for each half of the bridge if you like. And then our output FETs are under these clamps. Sometimes these come loose, these inductors as well. Seem pretty okay on there. Okay, cool. Another thing to look for is just on a first visual inspection, look for any damaged surface mount resistors. If you see damaged surface mount resistors, then you know that something's gone pop in the output section. So let's just grab my tweezers, if I can find them real quick. Where the heck is my tweezers? There's some tweezers here. Does anybody else have like a favourite pair of tweezers that they like the most? I've got loads of tweezers, but I've got a favourite set. Okay, never mind, we'll use my not favourite set. So yeah, have a look for blown surface mount resistors. A couple of 100 ohms there, got a, that one's usually fine, it's high resistance. You want to look for low value resistors that have like cracks or burns on them. Okay, and also on the driver cards themselves. Have a quick look. They all look okay to me so far. Okay, so now let's take our multimeter and see if we've got any shorted output FETs. I'm hoping I can do this. Can I do this without taking the clamps off? Maybe I'll just take the clamps off. Have a sneak peek under here. Okay, let's have a check, see what we got. So, from drain to gate, drain to source, no short there. Nope, no short there. No short there. No short there. Okay, all looking alright so far. Cool, no shorts or anything on the output FETs. So now we're pretty safe to throw some power into it and see why it is here in my workshop. Morning from the States, how's it going? Good afternoon from the UK. Hope you're good, buddy. If you've got a really nice tweezer set from your son and you never use them because you don't want to bend them, I mean, yeah, I can kind of get that, but at the end of the day, you can just bend them back and they're tweezers. Got to use them for what they're designed to be used. Here's my favourite set of tweezers. I don't know what I like about them. They're just about enough malleable that I can bend them into new positions without having to, you know, without them bending by themselves or without them breaking. They're decent sharpness without being too sharp, so stuff doesn't just ping and fly away. They're resilient, they've held up really well, they've got a good spring to them. I don't know, they're nothing special, but they're just kind of like my favourite set of tweezers for doing stuff with. Okay, cool. So let's hit some power and see what we got. So let's start off by probing. Let's go out and probe the output FETs, seeing as we've got the clamps off. So let's touch the remote for a fraction of a second. When on these JL Audios, when you just touch the remote for a minute, you get this kind of circuit starts to power up, and you get a little bit of oscillation, especially in the drive circuitry. So that's kind of useful. So we might see some pulses on the gates, but I can't quite get to them because the drive card's in the way. So I'm going to let it build a little bit of rail voltage and just see whether we have some output here. Okay, there we go. Oh, that's interesting. That actually doesn't look good. Yeah, okay, so have a look at the scope here. So I'm just probing one of the drains here. So that duty cycle is way too low. Okay, I'm just kind of pulsing the remote, just bringing it up a little bit. All right, let's try the other bank. Ooh, that other bank is not being driven properly at all, is it? Okay, so we have a drive circuit fault on our hands. That's very interesting. Okay. Okay, so no dead FETs, but no drive on this bank over here. Yeah, that's looking pretty stanky. So we're getting pulses on one bank. The duty cycle is too low, but the duty cycle being low is probably as a result of the other bank not actually oscillating there. I think they kind of like, when one's working fine, it kind of sets the duty cycle of the other. They kind of work in tandem. So yeah, whatever the issue is with this side, it's causing there to be an issue on that side, but the problem we need to fix is over this side. So yeah, no dead FETs though. I'm just trying to think what's the best way to approach this. Do we just strip it out from the case entirely first? I think probably that's the best thing to do. Now the problem with this amplifier is going to be in one of probably 3 places. So we're either going to have a problem on this driver card here. Okay, so it contains some of the components for this channel, if you like. Got drive IC on there, stuff that works with the bootstrap, etc. Then we've also got a drive IC down here, U5. That could also be bad, causing the issue here. Or if it's neither of those things, the issue could be being caused by the circuit that actually generates those pulses, which I think, I've never really had to go this far back in a JL Audio, but it's either around this section here, or there is actually some more circuitry underneath this preamplifier card that is responsible for generating the pulses, turning the audio into class D basically before being sent to the output section. So there's a few things there's a few different ways that we could approach this, I think. Try and think what the best way to approach this is. Naturally, we've got a situation here where we've got 2 separate channels. One of them is likely working fine, one of them is bad. So the one that we have that's working fine is kind of like our key. It's like a working example, and we can use that good channel to diagnose the bad one. One really cool thing we can do is we can swap parts from the good side into the bad side to speed up the diagnosis process, because obviously once we swap the bad part, the issue will move from the good side to the bad side, and from the bad side to the good side. So that will be a really easy, quick way of finding the problem. However, to do that, we would need access to probably these chips and these components, which would require removing these driver cards entirely. So we could swap the driver cards around, which would mean stripping the board out of its case, which I think might be the right thing to do anyway. But I'm just kind of having a little look around, because sometimes these drive circuit issues can be something as simple as a snapped solder joint or bad solder connection, which we could very quickly fix without taking the board out of the case, just by resoldering something on one of these driver cards, and then that's a much cheaper repair for the customer. So yeah. I'm just going to do a little bit more visual inspection, just to kind of have a look and see if I can see anything untoward or dodgy that could be causing this drive circuit fault here. I've had a few issues with surface mount solder cracks recently on some amplifiers, so I'm just kind of having a look for evidence of that. Looks okay. JL Audio use a pretty decent solder. You know, their assembly quality is pretty good. Don't usually tend to see cracked solder joints on these JLs, so okay. I think what we should do is we should probe a little bit more and see if we can follow the pulses coming from the Class D generation circuit into the drive circuit. So I'm going to bring up the data sheet for these drive ICs here, just underneath the board. Just at the bottom of this driver card here. I think these are, what are these? XC424220. Or is that IC? IC. I can't remember exactly what chips these are. Oh, 4420. Okay. I've made this mistake in the past when repairing a JL Audio amplifiers. I see a MOSFET driver with 4420 and I instantly assume that it's an IR or IRS 4420. So let's have a quick look. Is it IRS or is it IR? Here we go. So there is a chip, I think, called the IR4220 or something similar to this. And sometimes for JL Audio amplifiers, I've ordered these by accident and it's actually not been them. So it's been something, I think it could be the HEF or the HIP. I can't remember what the actual prefix of it is. TC, here we go. It could be the TC4420. So let's have a look at this. And let's have a look at the pin out and see if it matches what we've got in our amplifier. So we should have VDD on pin 1 and 8 by the looks of it. Input on pin 2, nothing on pin 4 or pin 5, and output on pin 7 and 6. Okay. So provided the chip that we've got in this amplifier is in fact a TC4420, we should have nothing on pin 4 or 5. So that's one easy check that we can do first. If we've got pulses or voltage on pin 4 or 5, then we know that we have the wrong chip. So it's probe pin 4. Nothing so far. Pin 5. Nothing so far. Pin 4, 5. That's good. So input was pin 2, was it? Yeah, input was pin 2. So let's have a look and see if we've got any pulses on pin 2. Yeah, there we go. That's got some pulses on pin 2. Okay. Let's check to see whether we also have pulses on pin 2 of this side. Yeah, we do. Okay, cool. So this is definitely the TC4420. So we have pulses on both inputs to these drivers here. So they're getting their inputs. Now let's see if we have any pulses on the outputs. Okay, we've got pulses on the outputs of this 4420. On this side, this is the good side. Now let's check the bad side. Yep, we have pulses on the output for the bad side as well. Okay, cool. So those are the, I'm just going to call them the low side drivers for now. The other ones, we have 4 of those chips. The other 2 are on the upright driver cards. So let's turn this up so we can see a little easier. And try and get to probing these ones. Without removing anything. Okay. So pins 5 and 6 are outputs. So I'm just going to probe pin 5 and 6 first because that's really easily accessible here. Okay, we've got no outputs from this IC here, this one. Do we have any output from this IC? Yes, we do. Okay, so there's no output from this MOSFET driver here. The interesting thing will be is if we have input. If we have input but no output, then we know that this chip on this drive IC is bad. See if I can get my probe in there without shorting anything out. Ah, okay, we've not actually got any input to that drive IC. So that drive IC is probably fine. I just probed pin 2. Don't know if you can see on the oscilloscope screen there, but basically, yeah, there was no... Actually, is there any VDD? So VDD, we've got 9 volts going to that one. Actually looks like I've got a couple of pulses on there, which isn't good unless it's just a poor ground connection over here. Oh yeah, that's on the ground as well. So yeah, no input to pin 2 over here. The input should look like, if we can maybe get our probe in here and probe this one over this side. There we go. Yeah, so we've got good pulses on that one. So basically, pulses aren't making their way to this driver card for the input to the drive IC. Okay. So now let's take a look and see whether the issue is on this card or whether it's an issue with waves being fed to this card. So we're going to go ahead and probe the pins on the back now, coming from the main board, and see what they are. So we're looking for pins that have pulses on them, and we're looking for one pin on this card that doesn't have a pulse where it should do on this card. So let's get a reference of where the pulses are for each card. So we've got 1, 2, 3, 4. Okay, so pin 4 should have some pulses. That looks like an output. Pin 5. Pin 5 has a little bit of noise on it, but not much. Pin 6, pin 7, pin 8. Okay, pin 8 has some 3.8 volt RMS pulses on it. I suspect that's the input. So if we go ahead to look at pin 8 on this card, interesting. We actually do have pulses coming from the main board to this driver card. So I would say that the issue is on this driver card, somewhere between where the pulses come in and the drive IC. So which one's the output? Is it pin 4? Yeah, pin 4 is the output. 1, 2, 3, 4. Nothing on there. Okay, cool. We're getting somewhere. I think we are honing in on the issue. We just need to find it now on this little upright driver card. Now, just because we've had the drive circuits powered up a couple of times, I'm actually going to go ahead and take my thermal imaging camera and just have a little look and just make sure nothing is getting too hot over here on the output section. It's always worth doing, seeing as we have it here. So let's take this thermal imager, have a quick look and just double check, see if anything is getting hot on this driver card. Okay, that all looks pretty normal to me. We've got a bit more heat on this driver card, but that's because it's actually doing work, whereas the other one isn't actually doing work yet. Yeah. No, that all looks fine. I'm happy with that. Why don't the pulses look the same? The pulses don't look the same because this is a full bridge amplifier. Okay, so one of the channels is out of phase with the other channel. That's why the pulses don't look the same. Right, let's turn the power supply off. Okay. So let's turn our attention then to the output driver cards. I'm going to try and get something to hold this upright so that we can work on it a bit easier here. What have I got that could do that? Maybe a towel or something here. Okay, it's a bit better. Okay, so yes, have an issue on this driver card. So let's try and figure out, where do the pulses go? So they're coming in on pin 8 down here, and then we can't really see a trace because it's so tight in there. So I'm going to take my multimeter and I'm going to try and find continuity for where pin 8 comes in on the driver card and see where it goes, and then we'll find hopefully our faulty component. So let's probe the back of pin 8 where it's nice and easy at the back here, and let's try and find continuity. Okay, there's pin 8. So we have a transistor here. Let's see if it's on any of these legs of this transistor. Okay, so we have continuity to this transistor right here. It's pin number 3 of this transistor. So I just want to make sure that we have continuity to that pin 3 of that transistor as well on here from pin 8 coming in. Yep, we do. Now let's just check the transistor to see whether the values that this transistor is reading on this bad card are different to the good card. So we've got 578 on this one. And we've got a 579, that's about the same. And flip the probes. Got a 9, about a 980 on that one. Yep, that's similar. And a 571. And a 571. Okay, so they're working. They're giving me the same readings on the multimeter. So the next thing to do would probably be to try and probe them with my oscilloscope and see where the wave disappears. So we've got it coming in from pin 8 on this third leg. I don't know if I can like really show you this any clearer. It's very dark on the camera here, isn't it? Yeah, you can't really see the pins in there, unfortunately, where I can. I don't know if there's a good way to show this. You can see if I turn it up a little bit more like this. So yeah, pin 8 is coming in there with our pulses on it on this third pin, and we want to see where the pulses go on the rest of the 3 pins here. So let's turn the power back on. So let's take a look at the good card first, which is over here. So this pin 3 is where the pulses come in. On pin 2 we have some DC, looks like maybe 20 volts. What do we got? So on this second pin we have 30 volts DC with PWM riding along it. Okay, that's what we should have. And pin number 1 we also have PWM. So on this side we have PWM coming in on pin 8 here. Then on pin 2 we have, okay, yeah, we have PWM riding along DC and PWM on pin 1. Okay, so that's fine. That's all working okay. Now, where does that move along to? We have PWM riding along that high voltage DC, that sort of 30 volts there. So what we should probably do is we're going to assume that the pulses riding along 30 volts are the output. That's what the circuit wants. I would imagine. So we're going to go ahead and probe the output of that, which is the middle pin here, and see where that goes next. Where does that go next? The cap on the left looks bulged. Which cap? This one? This one? Nope, these caps are fine. So we have output from this pin here. Where do you go? I think it might go into this tiny transistor that I can't quite get my multimeter probe around to pin 2 of. It might go into pin 2 of this transistor that I can't quite reach. I can't confirm that. Come on, just touch on that transistor just for a fraction of a second, just so I know whether it goes in there or not. Okay, I don't think it goes into that transistor that I can't reach because I think I've touched it by now. Where do you go? Where do you go? Pin 2, output of the transistor. Ah, it goes into this transistor at the top here. Here we have a A1070. Okay, cool, so we're going into another transistor at the top. So let's have a look at the transistor at the top and let's compare multimeter readings. We have 571 and 570, that's about right. And we have a 588, 585, and that is open. And that is open. Okay, cool, so they're reading the same. Let's turn our power on again and follow the pulses, see what we've got. So that goes into pin 1 of this transistor here, pulses with DC. Pin 2, we have, okay, pin 2 looks kind of like this. Looks like some DC with a little bit of pulse, but not much. Pin number 1 looks like this, DC with pulses, but not much. Let's compare that to the good side real quick. Good side, we have pulses coming in on pin 1, as we expected. Pin 2 has, now that's different. So on the good side, we have pulses coming in on pin 3. Pin 2, we have less DC voltage. We have 10.05 volts here. Okay. So on the bad side, we actually have much, I was going to say much more voltage, but we don't actually. We have about the same, 10 volts. I thought it was more than that a minute ago. 10.2, that's actually about right. That has a bit of noise on it. What about the good side? Good side has less noise on it. So this has more noise on it, this one. Has some pulse on it. So I'm wondering whether this transistor might be leaky. Okay, so that's something to bear in mind. It could be an issue with this transistor, this A1070. So let's just bear that in mind and let's continue digging a little bit. I'm just going to go ahead and probe a couple more points on these driver cards while they're powered up, just to see if I can see any obvious differences between the two. So the good side, we have nothing on that one, and 9.5, 9.7. Nothing. Yep, cool. Got some DC, no pulses really. Got some DC. Okay, looks about the same. Got a 10 ohm here with 10.2, 10.25, 10.2, 10.25. Okay. Are these just PWM drivers for the switch mode power supply? Nope, these are the output section. This is a Class D MOSFET drivers. Nice work, Stephen Nelson. Great job. Found a couple of bad parts in your amp. Good, it feels good, doesn't it? It's a nice feeling. Okay, so let's continue on. Pin 2 from this one. Looks a little different. Where does that go? Maybe we should work our way backwards actually from the drive IC. So the drive IC on here is the 4420. So let's work our way backwards from pin 2. So we have pin 2 on the 4420. Let's work our way backwards from there, see where that goes to. Doesn't really seem to go anywhere. Maybe that's the issue. Maybe it's a broken trace. Where does it go on the good card? I apologise, you guys can't really see anything, but it's very difficult to get a camera on this at this angle here. I'm actually struggling to find what connects to pin 2, the input of this drive IC down here on this card. It's just at such a crazy angle that it's very difficult to probe around. There's two components that I can't probe all of the pins for because they're just like two at a strange angle, and it would just be my luck that it just happens to be one of those components that actually has continuity to the input pin, wouldn't it? Yeah, let's grab the print. Strictly Amps. Thanks very much for that. That'd be really helpful right now because it would prevent me from having to dismantle this thing if it's just a surface mount issue. Do you have the diagrams of these driver cards though? Alright, let's have a quick look. Oh, strictly amps. No, this is we've moved on from the Hertz. This is a JL Audio 1000/1. Thank you so much for the Hertz schematic though. Right, where the hell does that go? Pin 2, TC4420. Where do you go? You seem to connect to this pin of this IC here, but I'm not getting any continuity when I probe you. No, you don't go to that IC. Oh wait, you do. Okay. I think you do. Okay, so yeah, I found what the drive IC is connected to on the input. Right, let me just try and zoom in. I'll try and show you exactly what I found here, because I know this is very hard to follow, where you can't really see anything. So, on the driver card here, we have, if I can move this cap out of the way perhaps, we have the output drive IC here, okay, TC4420. On the bad driver card, we're not getting any input pulses to the input pin. And I've been trying to find out why. We're getting input pulses to the card itself through the headers, but somewhere along the way from pin 8 over here, it's not making its way to the drive IC, the TC4420. Now I was trying to find what was connected to the input pin for the TC4420, which is this drive IC right here, and it's actually connected to this tiny component here. This is like a little 5-leg component right there. So I now need to somehow probe or work out what this component is, so I can look at what legs to probe to try and figure out whether that's the issue, why we're not getting any drive on one bank. 1000/1, yeah, old school one. I'm just going to probe a few pins while I can, just the ones that I can actually reach and access here, which I think is all of them actually, apart from the one that connects to the drive IC, so that's good. It'd help if I could see the markings on it, but I don't see the markings on it, so I'm not sure what it is. Right, so this top pin here on the good side, let's have a look at what you are. Okay, you are pulses, 2.7 volt RMS pulses. And on the bad card we have, no pulses, just 5 volts DC. Okay. It comes down from there. Comes down from there. This is one of the older ones. This is, yeah, I'm not sure. The revision is, can I even read the revision? PCB 102, hold on a minute. Revision 8, this is a Rev 8. You know what? I'm actually wondering whether the issue is this larger chip here, this A2611. And the reason I say that is because, okay, if we have a look at the good board here, see this larger chip, okay? Basically, it seems like this larger chip feeds the drive IC on this card with its PWM. So it looks like we have an output from this big chip into this tiny little 5-pin IC just down there, which then feeds the driver itself, which is currently blocked from your view by this capacitor, but is here. Here we go. So we go from here to that little chip to that chip. That's what it looks like it's doing. So on the good side, the output of pin 6 is pulses, and they seem to go into this tiny chip here on this top pin. However, on the bad side, we don't have any output at all from this chip. We just have 5 volts, 5.3 volts DC, which might be the chip's fault, but it also could be an issue with the input to the chip. But if we take a look at the inputs are PWM on 2 and 3 and PWM on 2 and 3. 1.2 volts RMS worth of PWM. It's a bit lower amplitude PWM, but it is there. 1.8 and 1.0. So the PWM is present on pins 2 and 3 of this chip, albeit a little low amplitude compared to the other side, but it is definitely there. If we zoom in a bit on the scope, let's have a look at the amplitude of these waveforms. So we're going up to 2 bars and 1 bar. 1 bar and 2 bars. Yeah, so the pulses are actually fine going into this chip. So I am willing to bet that it's actually this chip, this A2611, that's actually bad. Which I've never had before on one of these, but it's possible. Strictly Amps has very kindly sent me the schematic for the 1000/1 V8. Thank you very much, buddy. That's awesome. Let's have a look and see whether it has a schematic for the output driver cards on it as well. Cliff, let me know if you're happy for me to like show my phone screen on the camera or not. I don't know if that would get you in trouble, if the schematic was out there. I don't know. So, sometimes I'll speak to technicians and they say, hey, don't show this schematic anywhere. So I always double check first. So I'm just having a quick look to see if I can find the page that has the output drive card on it. You should swap chips. Yeah, I could swap the chips. Yeah, would be pretty easy. Really easy to do. That's the power supply. Input and crossovers. Amp section. 2611. Strictly Amp says might not want to. Okay, that's cool, buddy. No worries. Thanks for sharing it anyway. So I'm just having a look now, seeing where the gate path goes. So we have pins 7 and 8 of the 4420 driver. Yep, that's as expected. Pin 2 is the input, I think. Yeah, pin 2 is the input, although it seems to go all the way around. All the way around here. 502. Do you still struggle to get components? It depends what they are sometimes. 12 volt in, we go up there. High side drive input is reference to that. We've got a resistor. Pin 2, pin 1 and 8. TC4420. Yep. U500 and 501. I don't think that's what these are. I don't actually know. I'll tell you what it is. Cliff, the high side drive cards aren't actually on the schematic here. On the schematic there is a little maybe if I zoom in, here we go. I'm sure I can zoom in and just show this tiny section, right? I'm going to zoom in and just show what it has for the driver card that I need. It's just a square with the pinouts on it. It should be alright to show, right? But basically the schematic just has a block diagram for where the high side driver card should be. I don't know if it actually has a schematic for that card. It's always the way, isn't it? Always the bit that we need is on some driver card that's not actually listed in the schematic. Kevin says the chip is called a HCPL2611. Nice one, thanks for that, Kevin. So yeah, I think one of the cool things we could do, I guess, is we could swap the good chip with the bad chip and the bad chip with the good chip. That would tell us where our issues are, if we have actually got that right. But I think it might be best maybe just to order a new one. I don't want to damage the good card or anything in any way, but I'm thinking maybe don't do that. I'm thinking maybe maybe just order 2 new chips and replace both of them. HCPL2611. Let's have a look at that on the internet. Let's see if our pinouts match up. Oh, it's an optocoupler. Oh, that kind of makes sense as to what we're seeing here. So the 2611 is going to be here. We have input on 2 and 3, anode and cathode. Oh no, sorry, we have input on pin 2. Yeah, input pin 2, that makes sense. And then we have output on pins 7, 6, and I think it's what was it? Pin 6. We had our output. Yeah. Oh yeah, so we had input pin 2 and 3, output pin 6. Yeah, that actually matches up perfectly. VCC pin 8, ground pin 5. Okay, let's just check that the VCC and the ground are right. So VCC pin 8 and ground on pin 5. So we should have some DC voltage here on pin 8. We have 5.3. And should have ground on pin, that one. Yep, that's correct. Alright, awesome. So yeah, it's just an optocoupler. Okay. Right then, so yeah, just need a new optocoupler for that then. That is a really strange one. Very, not that common for an optocoupler to die over here. I guess we'll have to buy another one of those then. We don't necessarily need to buy the exact same optocoupler that is fitted here. We could replace both of them with something compatible, but let's just see whether any of my favorite shops have them in stock. RS and Farnell. Okay, cool. RS has 147 of them in stock, as does Farnell. Cool. Is it me, or does that package look like through hole but surface mount through hole? What's with that? What's with this cursed image here? It's a dip package, but it's got bent pins to surface mount it. It's a bit weird. So, oh yeah, surface mount dip. Would you look at that? Don't think I've ever come across a surface mount dip before. Interesting. Well, I don't want that. I want it not to be the surface mount version, please, if you have it. Tomo is out for coffee, nice. You can bypass it then if it's an optocoupler to test it. Not quite, because an optocoupler will not just like work in some form of protection, but it will also allow two circuits to couple where they have maybe different DC offsets. So in this case we have PWM on pins 2 and 3, the inputs, and then a single output on pin 6. So I don't think that we have a way to bypass that. Yeah, that's the one that I need. I don't know why it automatically took me to the surface mount through-hole version. What's the difference between these two? Ah, different manufacturers. Okay. Different high voltage ratings, but pretty much the same on everything else. This one's a little bit cheaper. £2.11 each. Okay, don't need those anymore. I think I might just get them from RS because there's something else that I want to get from RS at the same time, so it'll make sense. Let's check that one's the cheapest. No RS, I don't want 50 of them. £2.85 each in a pack. What's the difference between these bottom two here? Is it the same datasheet? Different datasheet. Different datasheet. Different datasheet, same product. Specifications, same. Well, what's the difference then? Oh well, I'll just get a cheaper one, whatever. Okay, cool, that's my basket. I need one of those, two of those. I'm still paying delivery because I haven't built up a big enough order yet. No worries, we'll build up some more stuff, I'm sure. Okay, so I'm going to put this amp to one side for now then, because I can't do anything more on this until the new optocoupler arrives. I don't really want to swap them round and see if that makes a difference. Well, I could do. What do you guys do? You want to see if we swap them round it makes a difference? You probably do, don't you? You probably do, don't you? You probably want to see if we swap the optocouplers, does that cause the side that was bad to be the good side and the good side to be the bad side? Alexandru says no is stressful. Well, I mean, I've got to take them out anyway, haven't I, to replace them when the parts come, so... You might be thinking, what am I doing? Why am I using hot air? That's actually a good question. I could use the big ass soldering iron for this. I've had good experience using hot air to remove dip package at crazy angles like this, so this was just kind of my gut instinct. Oh, someone said you added the wrong one to your basket. What's the difference between P-dip and dip? Yeah, I'll just use the bigger soldering iron. I'm not sure why I'm trying to use hot air for that. Okay, 8-pin dip, P-dip and 8-pin dip. So what is the difference? They both look exactly the same. P-dip is ceramic housing. Okay. Are there any benefits or differences to that? What would that make a difference? Is ceramic housing not ideal? Do 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 do. Okay, that's one out. Let's do the other side. Yeah, we're using the big iron for this just because it's got a much bigger surface area, so I can hit more of the pins at once, and it has more thermal mass, so I don't have to hold it on for quite as long for the heat to soak through properly. Just makes my life a little bit easier. There we go. There's the two optocouplers out. Now I've removed them, actually, I'm just kind of thinking I don't really necessarily want to stress these solder holes any more than they need to be. So rather than fitting those back in to swap them and see, yay, it works now, or it doesn't work anymore, rather than doing that and stressing the solder holes more, I'll just wait for the new parts to arrive and just fit those straight off the bat. I think that would be the best option, because I don't want to keep soldering and desoldering things unnecessarily when we don't really need to do that. So they're removed, that's fine. They can go in the bin because they're old, and even though one was working fine, it's best to just replace both of them anyway. So yeah, I think that's all good for this JL Audio. That should be fixed when those parts arrive, so I'll do another live stream when those bits arrive in the post. Let's have one last look at something real quick. I was planning on stopping this stream at about 5 PM, which is about half an hour's time. So we've got about half an hour left of the live stream. I can either look at JL Audio 500/1, 500/5, or something else. Something else which I can't remember because they're all not in the workshop yet. I'm going to put the clamps back on the output FETs because they're actually all fine. You know what it's going to be time for soon? Boom or Bust episode 1. Is anyone excited for Boom or Bust? Does anyone here seen my my videos detailing what that's going to be about? Or does anyone here not have a clue what I'm talking about? I have filmed the whole of episode 1 of Boom or Bust, and it was freaking awesome. I'm so excited to show you guys. Episode 1 was just with my own little test box. It was like a little aeroported box, as to set like a benchmark for you guys to try and compete against. And oh man, it turned out really freaking great. I'm so excited to release it. I'm going to be editing the video this evening. I've edited about half of it already. I'm absolutely excited. Very excited. Okay, does anyone want to take a guess? Right, seeing as you guys are here, okay, so episode 1, Boom or Bust, was just an aeroported box. It scales to about 2.7 cubic foot after displacements, tuned to 27 Hertz, with the idea of hitting most of the frequencies, as many as possible, between 25 Hertz and 60 Hertz. So we want to hit between 25 and 60. I have an aeroported box at 2.7 cubic foot scaled with a tuning frequency of 27 scaled Hertz. Okay, so How loud do you think that would be given about 500 or 600 watts clamped to the coil, which would be about a 1000 watt RMS amplifier? So let's say you've got a 1000 watt amplifier hooked up to a 12-inch sub and it's getting about 500-600 watts RMS after rise. How loud do you think it was at 25 Hertz? Let's get some guesses. Anyone want to guess how loud? Guess how loud it was on the loudest frequency, which is probably close to tuning. Is there a way to compare your optocoupler with your tester? That's not a bad idea. Yeah, let's just drop the not with my tester, but we can do it with a multimeter. So my transistor tester only tests 3-pin components really, but we can drop our multimeter and have a look to see if there's any differences on the multimeter between these components here. So the issue was on the output. So if we take a look at these, pin 6 was the output. Okay, so let's just do pin 6 to ground. So we've got nothing on this one. Okay, nothing on that one. Nothing on that one. Flip the probes around. Nothing on that one. Ah, there we go. So on this one we have 620 between the output and ground. On this one we have absolutely nothing. So yeah. How about the output in VCC? Output in VCC, nothing. Output in VCC, nothing. Output in VCC, nothing. Output in VCC the other way around. 1244. So I'd say this one's the good one and that one's the bad one, because I've mixed them up now. But yeah, that pretty much confirms that the issue is the optocoupler. We did actually find the problem. Got a few guesses. 115 dBs, 134, 136. Jesse says 136 or 136. Well, it could be either of those, couldn't it? Fuck. 120. 138. Correction. 138, 126. Okay, we've got quite a massive range of guesses actually, all the way from 115 to 138. Yeah, pretty interesting guesses. I won't. Yeah, issue found. Yes, Chris, issue has been found. Fortunately, so yeah, interesting. I'm not going to give any hints away as to if it was close to any of those. So, guess you just have to wait and see. I'm going to try and make Boom or Bust to be a weekly series. I said that I would try and make it a weekly series in the footage that I recorded the other day for episode 1. However, after editing the footage from episode 1, I'm now thinking, oh heck, I've got to do this every week. And it's like a whole day of filming, and then another day or maybe one day once I've got the format down, but 1 or 2 days of editing. So it's 3 days a week on Boom or Bust. So it might be fortnightly. I might do it weekly, I might do it fortnightly. Depends how it goes. Depends how they print as well. If I've got some issues where someone's design is taking a few attempts to print, then obviously that's going to add to the time that it takes, but we'll see. Someone says 2-inch, 92 dBs. Guess we'll have to wait and see then, won't we? Sam, I'm working on a Sundown SFB 1000. Can I shoot you a message regards to the defaced transistors? Yeah, man, absolutely, Jesse. No problem at all. Although if it's the 1000, then you're probably going to be looking to replace the output FETs with the RFB 4115s. They're pretty universal across these smaller amps. Actually, you don't even need 4115s. You could go for something like much less than that. Much less powerful. Maybe like even an IRFP 260 might be good. You could use you could probably use 100 volt FETs. So if you can find some 100 volt FETs that are at least sort of 60 amps, 60, 70 amps, something like that, maybe more, maybe like 120 amps, should be fine. The power supply FETs again are pretty. You can use 1405s. Or is it 1404s in a 220 package? I think it might be 1404s, 3077s. Yeah, there's like loads of different parts you can use. 7537s. Condone Yourself says I changed my answer to 113. What was your What was your guess before? Condone yourself like a professional. 126. And changed it to 113. Someone said, wait, I saw a question that was interesting. Hang on a minute. Can we buy the 2-inch driver to test as well? Yeah, absolutely. The 2-inch driver is in the documents on the video that I released, saying how do you design an enclosure for this. Yeah, the data sheet is in there, so you can find out what driver it is, and you can, yeah, for sure, buy one yourself, run some tests. It's not an ideal driver. The truth is, a perfect driver for this series I don't think exists. But while we've got an audience here, maybe you guys could help me, and maybe you guys might know of or be able to find a better suited driver for this. I'll explain what we need in a minute. I just wanted to have a quick... Good idea. Is it really scalable like that? Absolutely. So fluid dynamics is just how we listen to sound through air. It's how boxes work. Think about a little trumpet, like a tiny toy trumpet, okay? If you were to drag the scale button and make it bigger, that trumpet's going to work in exactly the same way, just at a lower frequency. The same way that a saxophone works by closing more and more holes to make the saxophone longer. You're basically making the saxophone bigger, longer, therefore lowering the frequency. Yeah, absolutely. It scales perfectly when it comes to the acoustics of the enclosure designs. The frequencies all scale as well in a same fashion with that. The only thing about this series that doesn't scale are the materials and the way that the drivers are made. Just because of, not because it's impossible to make a scaled 12-inch driver, like a 12-inch subwoofer. It's just nobody's asking for that to be made, so therefore nobody's making them. In order for there to be a perfect driver for this series, okay, think about a 12-inch subwoofer with 1,500 watts RMS. So it has a 3-inch voice coil with 4 layers of a copper winding on it. So it's a 4-layer, 3-inch voice coil, and it has a resonant frequency of around 28 to 30 Hertz. And it has something like, I don't know, 12 mils of X-Max. You know, quite a bit more than that mechanical. So in order to scale that down to a 2-inch driver, okay, we would need a 0.5-inch voice coil, okay, with a decent enough amount of copper on it to give it something like 30 to 40 watts power handling, okay. Now, that isn't impossible. That's not out of the realms of our abilities to produce a voice coil 0.5-inch in size that can take 30 to 40 watts continuously. That's definitely possible and definitely doable. The issue is that 2-inch drivers are generally used for full range. So when a manufacturer is producing a 2-inch driver, that driver is going to be used generally as a full range driver. Therefore, it needs to be able to play up to 20 kilohertz, and it needs to be pretty flat, and it needs to have relatively okay off-axis response. Now, a subwoofer driver, going back to our 12-inch driver, that doesn't need to play up to 20 kilohertz, obviously, but if you were to scale it, then it doesn't need, you know, a 12-inch subwoofer plays up to, I don't know, what, like maybe 150, 200 hertz. Okay, not that far. They're pretty slow, pretty heavy, pretty sluggish, pretty high inductance, I'd say. And yeah, they don't like to play up the range very nicely. So a 2-inch driver that perfectly matches with our subwoofer would need to exist that only played from like 120 hertz up to about 900 hertz, was inefficient, heavy, but powerful. 30 to 50 watts is a lot of power in a small 2-inch driver like that. And it would need to have around 6 mils of X-Max, okay? So there isn't really a need for a driver that fits that spec, is there? Like, that's like a mid-bass driver, but it's so small. Why, if you're going to use a small driver, why not just make it be full range? No one is asking for that driver to exist. The only driver that comes anywhere near close to that is this. There is one driver that comes sort of close to that, and that is this 2-inch subwoofer from Tangband. A really awesome little subwoofer. So it's a tiny little thing. and this has 5.3 mil of X max. It has a power handling, however, of only 10 watts. So a little bit, oh no, sorry, oh yeah, maximum power 20, rated power 10 watts. But it does have good X max. It has the right kind of idea behind it. The problem with this driver, and the reason that it wouldn't work in my series, is that this driver is already trying to mimic a subwoofer, not scaled. It's got an FS of 75 Hertz, and its characteristics and parameters are not that of a scaled 12-inch subwoofer, but of a tiny version of that sub. So it's trying to do what a subwoofer does, but in a small size. What we need is a speaker that doesn't try to do what a subwoofer does in a small size, but that does the same as a subwoofer at a scale. So 120 to 600 Hertz, whereas this driver from Tangband is designed to play between 70 Hertz and I don't know, 500. What does it say the frequency response is? It says it will go up to 2 kilohertz, but the issue with this is that the FS and the compliance is all wrong. This would scale, this 75 Hertz FS, that's like having a 12-inch subwoofer with a 12.5 Hertz FS. It's just too low, and it's not going to really perform well or scale well in your enclosure designs. So yeah, that doesn't work. But if anyone is aware of a 2-inch driver, has to be a 2-inch, can't be a 2.5, can't be a 2.75, has to be a 2-inch driver that is more tailored towards mid-bass, or that has specifications that lend itself well to this application, 20, 30, 40 watts power handling, designed predominantly for mid-bass applications with good X-Max, let me know. Do an American accent for your boomer bust vids. I've already done episode 1, so I can't change it now, unfortunately. But I want it to be chill. I don't want the boomer bust series to be cringy. I don't want it to be tongue-in-cheek. I don't want it to be like putting on an accent, putting on a show. I want it to be me, as I am, entertaining. Entertaining and educational and fun to watch, and good cinematic shots and good production value. Should be nice. Is that a new GoPro on your cam? No, this is just the Logitech Stream Cam. Yeah, so that's my issue with the driver choice. But the driver that I've chosen, it's okay. Its FS is a bit low. It scales to about 21 Hertz FS. Unfortunately, the actual resonant frequency of the driver that I bought is lower than it's supposed to be. The datasheet specifies it's supposed to be closer to 200 Hertz, but it's actually 129. So yeah, that throws it off quite a bit, unfortunately. But have you looked into the 2-inch Pro audio speakers from Celestion? I haven't actually looked at those. I don't suspect that they would have anything that works with that either. Like, the Tangband was going to be my closest bet, really. Like, it needs to be a company that makes speakers that are used in like iPod docks or like Bluetooth speakers. Like, you know, do you remember those iPod docks that had the 3 speakers? They had 2 full-range speakers firing forward, and then they had like a little subwoofer that was upward firing at the back. Does anyone else remember those? Really cool things. Now, that upward firing subwoofer is the kind of driver that we're probably looking for here. Something that was designed to be used in like a 2.1 or something style application on a very small scale, that was designed to produce only the lower frequencies or mid-bass frequencies and not do any full-range stuff. If the driver is bigger than a 2-inch, it will be too hard to print the 3D boxes. Not necessarily that's the issue. I am actually planning to use bigger drivers in future seasons of this series. But for now, I want to stick to a 12-inch. I want this first season to be for 12-inch sub. And when you scale it, okay, we're doing a scaling by a factor of 6. Okay, so we have a 12-inch sub becomes sorry, fuck it, what am I doing? A 12-inch sub scaled by a factor of 6 becomes a 2-inch sub. Now, if we want to do a 15-inch sub in the future, That's a 2.5. So if we do a 2.5 inch speaker, that would then scale to a 15 inch sub, which is not what I've said about season 1. I want it to be about a 12 inch sub. And then in the future, if we want to do an 18 inch sub, we use a 3 inch driver. So lots and lots of options for a 3 inch driver. There's plenty of speakers that I've seen that fit the task perfectly for an 18 inch driver in this style. But yeah, nothing that I've quite seen in a 2 inch. Girl says, I asked about the top cam, shows the board with a zoom. Okay, so the top camera that I'm using is this little JVC Envirio. It's an old kind of camera thing, and it's just got HDMI output into a capture card, and obviously I can zoom in and out like this. It's pretty cool. Yeah. It doesn't have the best macro focus, but it looks alright, to be honest. AliExpress sells them as clones of the JBL Mini Sub. You know what? I didn't actually think to look on AliExpress. Maybe I'll do that. Actually, I think a few AliExpress results did come up in a Google search that I did, and all of the drivers on there looked okay. They looked the right kind of thing for my application, but their power handling was just a bit too low. They were like 5 watt, 10 watt drivers, and in order for this to scale up to a typical kind of subwoofer, 1500 watts RMS, we need something that's like 30 watts at least. What about scaling down a 24 or 33 inch sub? Yeah, could be an idea for a future season. Do you personally prefer 12 or 15? I don't really have any bias either way. Really? I don't know. I've got 12s in my car, I've got a 12 in my car, I've got 15s in the van. Ah, someone said a laptop sub. Hey, that's not a bad idea. Laptops often have built-in subwoofers that are very small drivers that are dedicated to playing lower frequency band. You might be onto something there. I might have to look into that. That's a pretty cool idea. Laptop sub. Although, now the thing is, the problem with a laptop sub is it will be like 5 watts because it will be designed to be driven by whatever tiny amplifier is in the laptop. So that might not work. Maybe we should build our own. Guys, who's got the abilities to build a driver from scratch? Screw it. Hey, fuck it. I've got a 3D printer. We can 3D print a basket in 100% infill. Not a problem. We can 3D print a basket for a 2-inch speaker. That'll be fine. That'll definitely be strong enough. All we need now is we need a magnet, a motor that has a 0.5 inch coil gap that's wide enough for us to wind a custom voice coil that is that can take about 30 to 40, 50 watts of power. Then we need some spider material, some suspension material, and calibrate it for a decent FS of around sort of, what it would be? It'd be about 180 Hertz, 200 Hertz FS. And then you can buy 2-inch surrounds on eBay, AliExpress, Amazon, replacement surround kits. And then we just need a material for the cone. Nice and easy. We just use a bit of cardboard, a bit of plastic. Eminence will make you some if you can buy 50. I don't really want 50 of them. "3D print the spider." That's not a bad idea. Like, obviously it wouldn't be a typical spider material, but it would be, maybe we could do some kind of you know, like some kind of support spider where it's just like 4 or 8 kind of like bits of plastic, but then would they break under the fatigue of the vibration. Maybe then would they snap? Maybe, I don't know. They'll be great for subscriber giveaways. Yes, they would. And I'm sure some people would actually want to buy them from me anyway from the get-go, so they can actually mimic this series. Oh man, you guys have got my gears turning now. Maybe we could make it. Maybe we could get some brand to produce one as a one-off. Oh hell. Shit. Yeah, maybe. You know what we'll do? I think maybe what we'll do is we'll do season 1 as it is with the driver that I've chosen, obviously. See how popular it is. If the series is really popular and if it's getting like hundreds of thousands of views, like the Fan Showdown or like Derek's videos on Amp Dynos, if it's getting those kind of views, then definitely it would be worth approaching a company, seeing if they'd be willing to produce a driver for this application. Like you said, maybe 50 of them. Maybe they'd sponsor it even. They might even sponsor it. But yeah, that would be so sick, wouldn't it? Imagine getting a freaking custom driver built for this series. Alright, cool. Food for thought. Right, it's 5 o'clock. Time for my stream to end. Thank you for keeping me company, guys, on today's stream. Really appreciate you guys. I love streaming my work with you. It's really, really good fun. Love having a chat. And yeah, it's given me some food for thought. I never really considered that we could, you know, maybe do some kind of custom driver. That's really, really cool. Oh! Oh, wait! I just read something. Passive radiator. Yeah! Sub Dyno Man, yet passive rad and put a coil on it. That's a freaking awesome idea. Dayton make a 2-inch passive radiator like this in this exact kind of correct size. So all we need to do is make a voice coil for it, strap it, hot glue it to the back of the passive rad to the cone somehow, and then get a motor on the back of it, and there's our custom driver. Damn, that's not a bad idea. Not a bad idea. Okay, yes, a few ideas to go with. Right, nice one, guys. I'll see you sometime soon. The next time you see me will either be in another live stream or it'll be for episode 1 of Boom or Bust. So I hope you guys are as excited as I am. The footage looks amazing. I can't wait to show you. It's so fucking cool. Yeah, stay tuned. Subscribe if you're not already subscribed, and we'll see you in the next one. Take it easy.